Okay, so for number 6, what we're given here is we have a circle. It says here, define the radius in terms of the arc S of the central angle. So basically what we're going to do is take the central angle formula, which is S is equal to theta over 2 pi times 2 pi over r, and we're going to solve for r. So basically all I'm going to do is just cancel out the 2 pi's here. And so S is equal to theta times R. Remember, 2 pi and 360 can be used interchangeably. So many times when we're finding the length of the arc, we're going to measure in pi radians. So in this case, all you have to do is just convert that 360 to 2 pi and cancel it out. So your answer will come out to S is equal to theta times R. And because we're solving for R, we'll divide both sides by theta. So therefore, R is equal to S over theta. Okay, then number 7, which property is always true for quadrilaterals inscribed in the circle? And it's that your opposite angles are supplementary. So basically here I have a circle, we have a quadrilateral inscribed. So whenever you have a quadrilateral inscribed in the circle, angle 1 plus angle 2 equals 180. It has a supplementary relationship. Okay, now for number 8, we have a circle, and inside we have an inscribed triangle. And what is being asked of us here? It says, find the measure of arc in L. Well, that's easy because we have an inscribed angle in ML. So all we're going to do is take that 42 times 2 equals 84, and your answer should have been D, 84. Okay, number 9, if the radius of a circle is 3 meters, how long is the arc subtended by an angle measuring 30 degrees? So here I just used the length of the arc formula, 30 over 360. Now here, because they're giving us theta in degrees, I'm going to use 360 as opposed to 2 pi times 2 pi 3. So I just canceled out my zeros, so we're going to multiply 3 over 36 times 6. Now this time, because my answer are in pi radians, I'm not going to put that pi in my calculator. I'm going to leave it because it's going to be part of my answer. So I'm only going to multiply 3 over 36, which is I think like what, 1/12 times 6, which comes out to equal 1/2 pi meters. Okay, number 10, it says, for a circle with a radius of 6 meters, let me cover that up, it gets confusing, 6 meters, what is the measurement of the central angle in degrees subtended by an arc with a length of 7 pi radians? Okay, so right here is, we don't use that doesn't go along. This page got confusing for me. I printed this out. Okay, so basically what I did is I set up my formula, 7 over 3 pi. Now because my central angle was given to me in radians, or excuse me, this is when I goofed up. Hold on. Make sure I'm doing this correct. Okay, I brought it down here. I'm so sorry. I did. I used that one as my central angle. Okay, because my arc length is 7 over 3 pi, we're looking for theta. So my arc length is 7/3 over pi, 7/3 pi is equal to theta over 2 pi times 2 pi 6. My radius is 6. So what we're going to do is cancel out that 2 pi, and now we're going to get 7 over 3 pi equals theta times 6, and then we're going to divide both sides by 6. Now, what I did is, because my answers are in degrees, I went ahead and took this 7 over 3 pi and I converted that to degrees. So we're going to say 7 pi over 3 times 180 over pi. So all we have to do is cancel out the pi. And I'm going to do a quick little video after I go over this quiz on converting back and forth between radians and degrees. So all we had to do here is say 7 times 180 is 1,260. Bring our 3 over and divide, and that's 420 degrees. So now we're going to divide both sides by 6, but I converted that 7 over 3 pi to 420 over 6. and that is going to be equal to our theta of 70 degrees. So that one was a little more challenging because here we did have to do some conversions with this one. Okay, now the next question, angle ABD is formed with a tangent and a secant intersecting outside of the circle. If the minor arc is AC and the minor arc CD is 124 degrees, okay, and AC is 78, what is the measure of angle ABD? So basically, all we had to do first was take 360 minus 124 minus 78 to figure out that arc AD is 158. Then it was just a matter of saying, okay, 158 minus 78, this arc minus this arc divided by 2 equals 40 degrees. So our angle ABD would be 40 degrees. Now the next question is angle ACE is formed by two secants intersecting outside of the circle. If the minor arc BD is 28 and minor arc AB is 112 and minor arc DE is 112, what is the measure of ACE? So here we had to find arc AE by saying 360 minus 128 minus 112 minus 112, and that gave us 108. Then to find angle ACE, we're just going to say 108 minus 28 divided by 2 equals 40 degrees. So angle ACE is 40 degrees. And then lastly, ACE is formed by two secants intersecting outside the circle. If the minor arc BD is 28, oh, I just did that one. Never mind. Okay. So that gets us through number 12.